Wow. Hello viewers, welcome back to class. You're welcome to Master Builders Online Academy. If you are new in this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting content. Guys, don't worry. In this video, I have fully prepared myself so I can bless you, be a blessing to you. So all you need to do is to relax. I will give you everything for free. Just relax, sit well, eat well, and avoid every unnecessary distractions. Look at it. One of the things I'm about to do now is to teach you how to solve problems on moment of inertia under non-symmetrical figures. You see how amazing it is? Maybe you have been having issues with solving this problem or getting to admire people who solve problems under this category effect in regards. This is why I am here. So I can hold you by the hand and teach you the methodologies involved, the principles involved, the secrets and the ideas behind being able to solve problems on second moment of area, on irregular or non-symmetrical figure. I know you are excited, but do not skip any part of this video. This is for your own advantage because every part of this video is encrypted with principles that works. So when you skip any part, you may skip principles that will have helped you gain mastery over this aspect of this topic. So please and please do not entertain any form of distraction. And to appreciate me at the end of this video, don't forget to share this video. Don't forget to make this video go viral. Don't also forget to like and make positive comment at the comment section. Guys, if you are new in this channel and you have not get to access our videos on this, you can check the description below where you will see lesson 7 and lesson 8. This happened to be lesson number 9. Let's quickly jump into my marker board and solve this problem that we have before us. Problem 9. We are asked to determine the second moment of area with respect to the axis shown below in the figure. Now, a note here, all dimensions in millimeters, mm. Now we have a figure, and looking at this figure, I know you can judge or tell me the shape that this figure belongs to in your alphabetical letters. Is this A? Not at all. B? Oh no, not at all. Is this Z? No, I don't think so. Can you tell me? This shape here is an F shape. Alright, so you can be given any shape at all. One of the things is that any notable shape you will ever see is actually a combination of plane shapes. I section, combination of 3 rectangular sections. T section, combination of 2 rectangular sections. L section, combination of 2 rectangular sections. So F is equally a combination of couple of rectangular sections. But guys, what do we do here? Now, looking at this question, what we are asked to look for is second moment of area about the respective axis shown below. Now, S axis is shown. That means you are finding it about SS axis. Y axis is equally shown. That means you are still solving this with respect to y. It therefore shows that this question is not different from what we have solved before, only that we are given a different shape. And remember, as long as this is under the topic we have been looking at, moment of inertia or second moment of area, the same principle is required, only that you need to understand what you need to do. So we don't really need to solve thousands of problems. No. The same principle we use to solve a T section is the same principle we use to solve the I section. That same principle we use to solve I section is the same principle you will use to solve F section. Same principle you will use to solve Z section. Same principle you will use to solve P section. Same principle you will use to solve L section. Same principle you will use to solve any section at all, whether regular or irregular shapes. It's the same principle. So what do I need to do? Having known that I'm looking for the second well of area for this session, guys, what you need to understand is to check for symmetry. Why do you need to check for symmetry? So that you will know whether you are calculating y prime, y bar, or you are calculating s bar, or you are calculating both. Remember when we were treating I section, when we were treating T section, we mentioned that those two sections are actually symmetrical about y-axis, and as a result, we only find the center of gravity that lies in those axes. All right. So one of the things that this aspect of symmetry helps you to do is to help you identify whether the centroidal axis lies with S axis, lies with Y axis, or lies with both axes. So how do we get to calculate this? This is the question now. So let's check out if F is a what? Is geometrically symmetrical and dimensionally symmetrical. Okay. This is what we have as F section, for instance. Okay. This is what we have. Now, if I decide to divide this in the vertical direction, this is why. Why? What I have to the left is different from what I have to the right. Correct? Have you observed that? Similarly, that means this section is not symmetrical about y axis as long as the left end is different from the right end. Now, if I now decide to say, okay, let's divide it in S direction, S, then this becomes my top view and this becomes my bottom view. From my bottom view, this is what I have. Okay? But from my top view, this is what I have. Now, does the shape look alike? Not in any way. That is to say, this section is not also symmetrical to S axis. Therefore, an F section is neither symmetrical to S axis nor symmetrical to Y axis. Now, because of the fact that it is not symmetrical to S axis nor symmetrical to Y axis, the centroidal axis lies in both axes. In other words, we will be looking for S bar and looking for Y bar. But remember, when we were looking at T and I section, we were only calculating for what? Y bar. So this is the condition to know whether you are calculating for only S bar, only Y bar, or you are calculating for both X and Y bar. So when a section is not symmetrical to any of these axes, the centroidal axis lies on both axes. So what do we need to do? We now need to categorize, see how we can break this section into different notable plane shapes. And if we have this done, what do we achieve? Let's come to this shape. This is the shape that we have. So I can decide to cut this here, join it from here, then equally join this from here. So by the time I join this guy is already a rectangular section. This one here is a rectangular section, and this one is a rectangular section. So what do? I can decide to label this as section 1. I label this as section 2. I label this as section 3. This is the pattern of labeling. Section 1, section 2, section 3. So now that, listen carefully, listen carefully. Now that this section is not symmetrical about S axis, it's not symmetrical about Y axis. Listen, where do we now take as our reference? It's very simple. We will take the bottom, this axis as our reference line for Y, then we will take this as our reference line for X. So when we are to calculate the values for X, we will be using X as our datum. But when we are to calculate values for X, we will be using Y as our datum. So the next thing is that now that we have divided this figure into notable or plane shapes, We now need to identify what we need to obtain from this shape. What we are to obtain, guys, is not different from what we have been obtaining before. Not at all. Not in any way different. In any section, you obtain area, you obtain the centroidal axis or the centroid for that section, then you obtain the moment of inertia. Finished. But the primary thing that we find first is area and centroid of this section. So, how do we now position the centroid? Come here. Get this node, connect it together to get your diagonal, connect this to get the diagonal. So, somewhere here can possibly fall out to be the center of this section. If we draw a diagonal, where the two diagonal meet, that is the center of gravity. So, in y direction, you trace this from here to this point is your y1. Then the same way, being that this section is not symmetrical to x, is not symmetrical to any of the axes, this is your reference line in this direction. So from here to this center becomes the value of x1. Remember, anything you are obtaining from section 1 will have to take subscript 1. I have finished all I need to do about section 1. We will come to section 2. This is section 2. So get your diagonal again. Your diagonal. This point appears to be the center of gravity where the two diagonals will meet. Right? Now, if this is the point where the two diagonals will meet, I will equally trace out a line in this direction. This is my y2 from this reference line to this center in the vertical direction. But in the horizontal direction, it will still start from this reference line to where the center of this is. So you trace it down. This is what we have. This becomes x2. Now for section 3, get your diagonal, and somewhere here is proven to be the center of gravity. So you take it out again, parallel line to S axis, and this will give you y3. Then for x, we also trace down this. So when you trace it down, you have something like this. This becomes x3. Successfully, we have obtained the position for x1, x2, x3, y1, y2, y3. So what we need to do in each section now is to find the area, the centroid in s direction, and the centroid in y direction. Remember, when you are finding centroid in y direction, you use vertical distance. But when you are finding centroid in s direction, you use horizontal distance. Check it out. It's as simple as that. Now, what do we do? This is our solution already. So we have that in section 1. This is our section 1. In section 1, we will find A1, X1, and Y1. That's it. That's all. So for section 1, how do we get the area? The area 150 by 25. Correct? So we have 150 by 25. And this will give us what? 3750. 3750 mm squared. When you multiply 150 by 25, then the centroid would have what? X bar is distance of section 1 in S direction divided by 2 because it's connected to the reference line. Don't forget that this is our reference line at the left surface and the other reference line at the bottom surface. So now that I want to find this is my reference line. And remember that this section 1 touch this reference line. So therefore it becomes 25 over 2 and this will give us 12.5. Why the vertical distance? Remember that from here to here is the vertical distance of section 1. And remember that this section 1 has a direct contact with the reference line, right? So since you have a direct contact with the reference line, all I need to do is to divide 150 by 2. Then this becomes 150 over 2, and this will give us 75 mm. Now we have successfully obtained 3 values for section 1. The same thing we will do for section 2, and we will do for section 3. You see that the pattern is the same. Is the same. Okay, now we have section 2. In section 2, we will find A2, X2, Y2. In section 3, we find A3, Y3, X3, and Y3. That's all. So how do we find A2? We come to section 2. This is our section 2. Area of section 2. Length times breadth. So the length is given here. From here to here is given as 50. Just look at the dimension. From here to here is from here to here, which is 50 by 25. So we have 50 by 25. And when we multiply this will give us 1250 mm squared. That's for that. Then for the centroid, remember, this is where you need to pay close attention now. Okay? Another area where you need to pay close attention. Now remember, when we were considering section 1, in X direction and in Y direction, section 1 touches the reference line. It touches the reference line on this end. But now that we are considering section 2, remember this is the reference line. This is where S2 starts from. I want to find out. S2, which is section 2, does not have a direct contact with the reference line. Before you get to section 2, you have already passed a distance from the reference line. Is that correct? So what's the separation or the gap between the reference line and section 2? The reference line separation, the separation between the 2 points is 25. So you first of all pull down the 25 before you now take half of the horizontal distance of section 2. Remember, we are looking for horizontal distance, central, right? So we take from here to here was given to be what? 50. So we'll now divide 50 by 2. 50 over 2. And the central will have given us 50 mm. That is for x2. Now for y, this is y2. Now for y2, look at what happened here. This is our reference line. This is y2. Now section 2 does not have a direct contact with the reference line. So there is a gap. There exists a gap between section 2 and our reference line. So now that there is a gap between the section 2 and reference line, we need to consider that gap, that space in between the two. And the space between them is 50. So you first of all note that 50 before you now get half of the vertical distance of section 2. So put down this 50 plus half of 25. That is what will give you y2. 50 plus half of this. This is what we give you. So you find it easy. Then this would have given us 25 over 2. And this would have given us 62.5 mm. We are done with section 2. Now we'll come to section 3. Now for section 3, the area of section 3 is length, which is this end, by this. But the length of section 3 is not directly known. So how do we calculate it? Remember, from this end to this end is what is given as 100. But from here to here, if I trace this out, from here to here is 25. That means if I remove 25 from 100, from this surface to this surface, would have given us 75 mm. Right? Okay, because 75 plus this thickness, 25, will give us the overall width, which is 100. Correct? So we have that this is 75 by the thickness is 25, and this will have given us 1875 mm squared if you multiply the products. Are you there? Now for the centroid 3, again, this is our reference line, and centroid 3 starts from the reference line to the center of section 3, right? Now remember that this section 3 again does not have a direct contact to the reference line. There is a gap between the reference line and where section 3 starts from. Are you there? So what is that space in between them? The space between the reference line and where section 3 starts is 25, which is this thickness. So you put down 25, then now get half of the horizontal distance of section 3. And remember that the horizontal distance of section 3 is 75. Then this would have given us 75 over 2. And this will equally give us 62.5 mm as the centroid of section 3 in S direction. Are you there? Now let's get that of Y in Y direction. Now remember that this is our reference line now that we are considering Y. From here to the center of section 3 is the centroid of Y of section 3, which shows that from here to here. So look at it. Before we get to section 3, this is where section 3 starts from. We have already passed a distance of 50, 25, 50. So 50 plus 25 is 75, and 75 plus 50 is 125. That means before we get to section 3, or the gap between this reference line at the bottom and where section 3 starts from, which is the bottom surface of section 3, the gap between them, the space between them is 125. So that 125 will be noted first before you now consider half of the vertical distance of section 3. Are you there? That's it. So we have 50 plus 50 plus 25 will give us 125. Plus now, what is the vertical distance of section 3, guys? The vertical distance of section 3 is 25. So we have 25 over 2. And when we solve this, this will give us 137.5 mm. This is it. This is the first stage. Now we have just obtained the values that will help us calculate for the centroidal axis parallel to the base and the centroidal axis parallel towards the vertical axis. Are you there? So what do we do? Centroid. Centroid oil. The axis in both axes. So we start with I x bar. For x bar, this would have given us A1, x1 plus A2, x2 plus A3, x3, all over A1 plus A2 plus A3. So very quickly, let's substitute their values. A1 is 3,750 multiplied by x1 is 12.5 plus A2 has been calculated to be what? 1250 multiplied by 50, which is x2, plus A3, which is 1875 multiplied by y s3, and that would have given us 62.5 all over the sum of the areas. 375 0 plus 1250 plus 1875. Guys, without wasting much of our time, if you impute these values into your calculator and then divide, simplify, your final answer will be an approximate value of 33 mm. That's it. Now for y bar, this will give us y1 plus a2, y2 plus a3, y3 all over a1 plus a2 plus a3. And now what is a1? 3750 multiplied by y1 was 75 as calculated, plus 75 as calculated, then plus a2 is 1250 multiplied by y2 62.5 plus a3 1875 multiplied by y3 137.5 all over the sum of the areas, which include 3750 plus 1250 plus 1875. When you punch this into your calculator, simplify with your scientific calculator, you will have a final or an approximate value of 90 millimeters. So this becomes 90 millimeters. This is our answer. Now we have successfully obtained this centroidal axis. Now take for instance, you are asked to find center of gravity. This is where you stop. That's what the question requires. Okay, if the question requires you to calculate only the center of gravity in S and Y axis, this is where you stop. Or the question requires you to find the first moment of area. This is where you stop. These are the first moment of area for this section, right? Now the next question, or now to face the particular question we have here, we are asked to find the second moment of area, not the first moment of area. So how do we go about finding the second moment of area? We said earlier that the second moment of area is the same thing as moment of inertia. Are you there? So moment of inertia, which is represented by an R. So we have that second moment of area about SS axis. For about SS axis, we said that this one will have ISX is equal to IXX1 plus IXX2 plus IXX3. This we will call equation 1. Don't forget that we have 3 sections. Section 1 has its own second moment of area. Section 2 has its own second moment of area. And section 3 has its own second moment of area. So by the time you calculate their respective second moment of area, then add them up together, you will finally obtain the second moment of area for the composite section. Remember, composite section, F section. Now what do? We'll start looking for ISS1. So for ISS1, this would have given us B1, D1 cube over 12 plus A1 into Y1 minus Y bar squared. Don't forget that when you are obtaining the second moment of area about SS, here you make use of the values in the vertical direction. Okay? Get it very, very clear. But by the time we are looking for the ones in Y direction, here we'll now be making use of what? The values in S direction. This is just the logic way of getting this known, right? So it's just understanding principles that matter. So these things, guys, are not really hard to the way most of us handle it. No, they are not hard. It's just for you to understand principles. That's how it is. Okay? Now let me begin to open your eyes the more. Alright? Now in furthering this problem, like we have here, it is clear to us based on the problems we've solved before now that these parameters here will be obtained from section 1. So when we come to section 1, remember that B, horizontal distance 25, vertical distance is what? 150. Is that correct? Yes, 150. So we have this as 25 into 150 cube over 12 plus the area 1. Area 1 is 3750. 3750 multiplied by x1, y1 is 75 multiplied by y bar is 90 all squared. By the time we simplify this with the help of our scientific calculator, we'll definitely have 7.88 times 10 raised to the power of 6. Simple as that. So we have 7.88 times 10 raised to the power of 6 and raised to the power of 4. This is it. Now for section 2 as well, we will have IXX2 will be equal to D2 cube over 12 plus A2 into Y2 minus Y bar all squared. As usual, remember since we have subscript 2 here, it shows that the parameters here will all be taken from section 2. Correct? So from section 2, knowing fully well that B represents the horizontal distance of section 2 is 50. So while the vertical distance is 25. So 50 into 25 cube over 12 plus area 2 is 1250 into 62, which is y2.5 minus 90 all squared. So you just find out that these things are just repeated things that we do. It's not something hard. Don't forget that these values are taken from here. Horizontal distance, vertical distance. Okay, so we put the values area and the other is what we just have as calculator. So the final result to this becomes 1.01 times 10 to the power of 6 and raised to the power of 4. This is the second moment of area for the second section. Now we calculate for the third, then we sum everything together. For IX3, this will give us D3 cube over 12 plus A3 into Y3 minus Y bar all squared. Alright? By this, we know that all the parameters there will equally be taken from what? Section number 3. And for section 3, this is the width horizontal distance and this is the vertical distance. So horizontal distance is 75 into 25 vertical distance over 12 plus area 3, 1875 multiplied by y3, 137.5 minus 19 all squared. By the time we calculate this will give us 4.33 times 10 to the power of 6 and to the power of 4. This is what you have. Remember that all these parameters were all taken from section 3, right? So when we simplify this with the help of our calculator, this becomes the final answer in standard form. So what do we do? Now that we have obtained the value for all the different sections, to get the general second word of area for the composite section, we need to add the 3 values together. It's as simple as that. So what do? In substituting into equation 1, we have that Isx is equal to the first value is 7.88 plus the next is 1.01 plus the other is 4.33 all multiplied by 10 raised to the power of 6 and n raised to the power of 4. Alright, using standard form then. By the time we sum up these values, our final answer would have been what? 13.22 times 10 raised to the power of 6 and n raised to the power of 4. This is the answer for the second moment of area about SS axis for this composite section, F section. It's as simple as this. So you find out that the same thing we have been doing before is the same thing that we are just doing right away. It's not quite different from problem 7, nor problem 8. Problem 7, 8, and 9, they are the same. Then you watch out for problem 10. Then you will blow up your mind more. Hope you are getting massive values for this lesson. Don't forget, when a man knows principles, he becomes a principal, right? And when you understand boundary conditions, you will not overstep your boundaries, right? So one of the things you must understand is seeking to understand principles and seeking to understand boundary conditions. These are the things that when you work with, you neutrally become a consultant in your area of specialty. It's as simple as that. So seek to understand principles, how things work. That's all, not how the problem, just how they are being approached. When you get it clear, my brother, it's simple. It's for a lifetime. All right. So stop learning to pass exam. Learn to know. That's how it works. Now, what will be the next thing? The next is that we should find the second method of area about y axis, and this we are going to quickly be doing using the center page. As simple as this. Using the second moment of area about y axis. Now, the second moment of area about y axis equally applies to these 3 sections. It's these 3 sections that will give us the second moment of area about y axis for this composite section. That means IYY will be equal to IYY1 plus IYY2 plus IYY3. This we will call equation 2. You already have equation 1. Correct? Simple as this. Now, coming to this end, remember from previous problems we solved, problem 7 and problem 8, when we were calculating IYY, which is second moment of area about y axis, we always don't consider this section. Why? Because the section was symmetrical about y axis. But in this case now, this section is not symmetrical about y axis. So since the section is not symmetrical about y axis, and we have found out now that the value of x1, x2, x3, and x bar all differs. That means this part exists for a section that is not symmetrical about y axis. So in this case, we now need to take our time to calculate I1, which gives us B1, d1 over 12 plus a1 into x1 minus x bar squared. So you see now that we are calculating IYY, we are using x centroids. That is as simple as that. Parallel, perpendicular. Okay, now if this is gotten, so what do we do? In this case, like I said, here, what you do to this, what makes this guy differ from here is that when you are calculating IYY, the length or the distance along S axis now takes the cube. So in other words, this guy is what will now take the cube, or better still, swap the cube, whichever way you will understand it better. But I must ensure that you understand it. That's my mission. That's the wise masters. Okay, now let's continue very quickly. Now, what is B? Just you don't need to crack your brain that much. Just come in. The first value you have. So this now becomes 25. We'll now take the cube, while the other is 150 over 12 plus area still remains the same. It's only the values in the brackets that changes. Into what x1 was known to be what 12.5. Then minus x bar was calculated to be 33 all squared. It's as simple as this. So from what we have here now, the same when we come here, we find out that this is the horizontal distance which we will cube as we have there. Then this is the vertical distance which we no longer carry cube. So we just put in the value. This is area 1, this is x1, then the x bar we calculated, we have 33 somewhere here. Is that correct? So by the time you use your calculator to have this computed, we will have 1.77 times 10 raised to the power of 6 and n raised to the power of 4. Okay, that's it. So I y2 will be b2 d2 cube. Now remember, in this case, it's b that is carrying cube over 12 plus a2 into x2 minus x bar. Remember, we are using x or 2. And from what we have here now, it shows that these parameters will be taken from section 2. And from section 2, the area that we have in section 2 does not change. So like I said, all you don't need to do is to swap what you have here. So this becomes 50. We now take the cube. Then we have 25. Then plus over 12. Then plus area, which is 1250, into the centroid 2. X2 was calculated to be 50. So we now have 50 minus x1, x bar is known to be 33, approximately 5. So we spare this. Here's like this. Don't forget that these values, as we have them here, we're taking from horizontal distance 50 cube, vertical distance this. That's what you have. Then put in their values and simplify. When you put this into your calculator and simplify, convert it to standard form 10 raised to the power of 6, we'll have 0.62 times 10 raised to the power of 6 and n raised to the power of 4. This is what we have. We are just converting so that we'll have uniform standard form. Okay? Now, I, y3 would have given us b3 d3 cube over 12 plus a3 into x3 minus x bar all squared. This is what we have. Now, when we progress from here, this would have given us, remember that these values should be taken from section 3. So without wasting your time, just come here and swap the values. This gives us 75. Now take the cube. While you have the other as 25 over 12. Then the area of the other guy becomes 1875 into x3 was calculated to be 62.5. So you have 62.5 minus s bar was calculated to be 33. So this is what we have. By the time you compute these values you just have on the board and simplify, you have 2.51 times 10 to the power of 6 and squared. Now we have been able to obtain the second moment of area for each of these sections. Now to now get the second moment of area about yy for the composite section, all we need to do is to add iyy1, all the i's yy together, that's all. So using equation 2, we put in the value of this, put in the value of this, put in the value of this, then sum of the result. We have I yy3 yy is equal to iyy1 was 1.77 plus 0.62 plus 2.5 all multiplied by 10 to the power of 6 and 4. Now, by the time we add up all of these values together, we will have this as 4.9 times 10 raised to the power of 6 and raised to the power of 4. So guys, this is what we have. We have just calculated the second mile of area about the respective axes shown below, about SX and about YY. For SX, this is the procedures we went through, and this is the value. For YY, these are the procedures we went through, and this is the value. You find out that it is the same thing. So if at all you are given an L shape to solve, for instance, it's the same. It's just for you to divide it into notable shapes. Either you divide it this way or you divide it this way. Whichever way you divide it, we have the same result. So we don't need to solve all the problems, but the problems we've solved so far, we believe so well that they have ability, the capability to empower you to solve as many problems that you will ever encounter under this aspect of second moment of area. We love you guys, and we cannot leave this on there. This is one of the reasons why we are out to make academics easy for you, most especially in the engineering cycle. Alright, so guys, do well to subscribe to this YouTube channel, do well to share this video and make it go viral, do well to like this video, and do well to give us positive comments at the comment section. Please guys, in order not to miss out on our mind-blowing content, don't always forget to turn on the post notification bell. It's once and for all. Do it, and we will keep you updated anytime we release content that will actually answer the current academic challenges that you have in your team. So guys, without wasting much of our time, you can check the description below where you will find the link to the next lesson. We love you guys. Thank you for watching. See you in the next class.